Hello everyone. In this video I'd like to talk about the mole concept. Okay, now the mole is a strange word for something that is universally used in chemistry, and it doesn't involve the furry little creature you see on the screen here. It's actually short for a German word called Molekulargewicht, which stands for molecular weight. So if we take a look at this, what is a mole? The mole is actually a counting unit. It's a humongous number. It's a humongous number to count things that are infinitely small. So again, if I wanted to write this out, it's again, I'm going to write it like this. Okay, 6.02 times 10 to the 23rd. That's the number of particles in a mole of anything. Okay, now because we do have small things, this doesn't amount to much as far as mass goes. Okay, there's not much of little atoms. Okay, however, it always contains this many particles. So if I had 6.02 times 10 to the 23rd moles of carbon, it would be about 12 grams of carbon. That's about 12 large paper clips worth of mass. If I had a mole of water molecules, so notice I just mentioned about atoms, but now let's talk about water molecules. So molecules, of course, are collections or combinations of elements. So an atom is just a carbon, molecule is water, and if I had a mole of water molecules, how many particles would that be? It would be 6.02 times 10 to the 23rd molecules of or particles of water. In other words, individual molecules. All right. Now, I could also have something called ions, and let's take the sodium ion. So it doesn't matter what it is, but notice I am using particles that are very, very small. But if I had a mole of ions of anything, it would be 6.02 times 10 to the 23rd particles. If I had a mole of basketballs, it would be 6.02 times 10 to the 23rd basketballs. If I had a mole of worms, I would have 6.02 times 10 to the 23rd worms. So it doesn't matter. This is a humongous number. I just want to show you how big it actually is. So if we take a look at this, it's actually with 23, let's see here, 23 spaces. 1, 2, 3. Oh, one too many. There we go. That's a huge, huge number. Again, a huge number to discuss something that's very, very small. So how big is a mole? Let's take a look at some of these examples here. If you had a mole of pennies, okay, so 6.02 times 10 to the 23rd pennies, and gave $1 million of it, which is 100 million pennies, and you did that, you gave 100 million pennies away a day to everyone in the world, it would take you 3,000 years to get rid of all your money. That's amazing. 1 mole of basketballs could create a new planet the size of the Earth. So again, 6.02 times 10 to the 23rd basketballs. One more. If you had Avogadro's number of unpopped popcorn kernels, so the little popcorn kernels that are unpopped, and again, Avogadro's number is 6.02 times 10 to the 23rd, and you spread them across the 48 states of America, we'd be buried in 9 miles of unpopped popcorn kernels. Okay, it's a tremendously large number. Now, what is a mole? A mole is 6.02 times 10 to the 23rd atoms, molecules, or ions. Again, I'm choosing things that are very, very small. The very, very smallness of these particles says that I won't get too, like the mass is manageable. Okay? So if I have 1 mole of sodium, it's 6.02 times 10 to the 23rd atoms of sodium. If I have 1 mole of caffeine, whoopsie, it's 6.02 times 10 to the 23rd molecules of caffeine. If I have 1 mole of ions, and this ion I chose, notice it has a charge here. Again, that shouldn't be any worrisome. Then you have 6.02 times 10 to the 23rd ions. I said atoms. That should be ions, but either way. Ions of S2 minus. Now, here's the weird thing. If I have 2 moles of aluminum, I just take 6.02 times 10 to the 23rd and I multiply it by 2. And you end up with 1.204 times 10 to the 24th atoms of aluminum. So double the moles, double the particles, okay? And finally, if I have 1.806 times 10 to the 24th atoms, how many moles is that? I would just divide that by 6.02 times 10 to the 23rd, and you end up with 3 moles of atoms of whatever, okay? All right, so when I do this, I also need to understand that a mole of particles, everything has a different mass. So let me argue this here real quick. If over on the right side of you, I have a mole of lead atoms, okay? So if I have 1 mole of lead atoms on the right side, and I have 1 mole of hydrogen atoms, okay? They both have 6.02 times 10 to the 23rd pieces. That makes sense? They have both the same number of pieces, number of atoms, okay? Atoms. 1 mole, that's equal. Everything's good. But now, think about this. 1 lead atom is humongous. It is very, very heavy. Very, very heavy. And the mole of hydrogen, which is the smallest atom we know of, is very, very light. It's very, very small. So even though 1 mole of lead is equal to 1 mole of hydrogen, and those particles are exactly the same number of particles, 6.02 times 10 to the 23rd, they have different masses. So actually 1 mole of lead is actually 207 grams. 1 mole of hydrogen is just 1 gram. Okay? So they have different masses. So even though 1 mole, yes, is 6.02 times 10 to the 23rd of anything, those anythings are going to have different masses. Let me give you another example before I go through this and sign off. If you think of a dozen eggs, 12 eggs, okay, versus a dozen bowling balls, do you have a 12 of each? And the answer is, of course you do. You have the same number of pieces. I have 12 eggs and 12 versus 12 bowling balls. That number's exactly the same. But which one weighs more? And you know that 12 bowling balls weighs more than 12 eggs. That's what a mole is all about. There's the same number of particles at 6.02 times 10 to the 23rd, but they will have different masses, okay, because those particles are bigger or smaller. So let's go through here. 1 mole of carbon, if you look on the periodic table, has a molar mass. Again, now this is something called molar mass. So when I talk about these things, I need to look up molar mass on the periodic table. Every periodic table will contain the molar mass of substances. So when I look at carbon, and I see the carbon on the periodic table, it's in a box. Here's carbon. There's 6 up here and 12.011 down here. This is the mass number, atomic number. This is the mass number, or also known as the molar mass. So we need a periodic table to solve these kinds of problems. So where do I find 12.01? I find it on the periodic table. What about 1 mole of calcium? It's 40.1. That's on the periodic table. What about 1 mole of chlorine? 35.5. That's on the periodic table. What about 2 moles of iron? Well, if I look up 1 mole of iron, it's 55.8. So what do I do? If I have 1 mole of iron, it's 55.8. But now I have 2. So if I double the particles to double the moles, I must have to double the mass too, and it's 111.6. Okay? 1 more. How many moles do I have if I have 81 grams of aluminum? Well, aluminum has 27 grams. 27 times 3 is 3 moles. 3 times 27 gives me 81 grams. So 81 divided by 23 gives me 3 moles. Excuse me, by 27. I just said 23. That's wrong. 81 divided by 27 is around 3. Okay? Now, when we get into the next video, we're going to start calculating these things using moles and Avogadro's number and molar mass. Okay? If you have questions, please email.